Hello, students. I am here to give you a little introduction to the readings by Thomas Kuhn because although they are in modern English, it was written in 1962 and he's an American, this may be one of the more challenging readings you've had because of the subject matter. So he is a historian of science, philosopher of science, and we talk about the ladder of abstraction. So it's going up to this level. So it's asking you to think, philosophically and epistemologically about science. So start with if you look in the module for this week, I created a page called Shoulders of Giants, and that refers to a notion of science as functioning cumulatively, and it comes from a quotation by um, Isaac Newton, who said to one of his friends, who later became his enemy, if I have achieved much, it is because I am on the shoulders of giants. So by working from what came before him, he was able to advance. Kuhn wants to question that notion that science builds cumulatively, and one of the particular problems that notion faces is scientific revolution. So we had the Copernican universe, and then in order to get to we had the Ptolemaic universe with the Earth in the center. And in order to get to the Copernican universe, it wasn't just adding some more information. You had to radically change the thing 180 degrees. So it wasn't cumulative, it was revolutionary change. And so so what you have available in the PDF is you have chapter 1 and then chapter 2, and then it jumps to chapter 6. And then there's also a PowerPoint below on that page that tells you how to get from chapter 1 to chapter 6 by outlining the different steps he's doing. But in chapter 1, he's just outlining what he's about. And so he raises some of these questions. He introduces the idea of normal science. Normal science is the way it works, everyday science. Everybody is in agreement on what questions are worth asking and the procedures, and you do it. But then what happens is you encounter these anomalies, these things that don't fit. So, for example, when the Ptolemaic universe people said, well, everything's going fine except Mercury reverses direction, and this, how are we going to solve that? And so what they have to do then is they have to come up with some solution to this anomaly. And every once in a while, if the anomaly gets too big and too persistent, you can't just have a little fix that fixes it. You have to change everything entirely. And so in that first chapter, he's talking about these things and these conceptual transformations. And one of his points of chapter 1 is that history could do the job. History might be up to the task of explaining how normal science and then this notion of a paradigm basically functions, and then how you can get a better explanation of how science progresses, not by looking at the done deals, but by looking at the research that's going on as it's going on. You get to see how science actually proceeds rather than what you would think was the process if you looked at from discovery to a new discovery to a new discovery. That, he says, gives us a skewed vision. So the point of chapter 1 is to tell us that we have a skewed vision of the history of science, and he's going to help fix that. In chapter 2, he goes into the fact that the development of a paradigm and a mature model that everybody's in agreement is really good at kind of identifying anomalies, things that are wrong. And then what happens is, in order to resolve the anomaly, you have to change the paradigm. So that's the way this works. And one of the consequences of normal science is eventually everybody's in agreement, and then you come up with a textbook, and we're all in agreement what the textbook says. And once you're doing that, people practicing normal science get more and more detailed, they get better technology, and they focus on tinier and tinier things. And suddenly, the average person, the layman, is left out of it entirely. The average person can no longer participate in science once it has a fully developed paradigm and gets down to little tiny nitty-gritties. And so this happened at different times in different fields. He says it was achieved among astronomers in antiquity. Students of motion got their paradigm figured out in the Middle Ages. Uh, Physical optics in the late 17th century, and that was with Newton. Historical geology in the early 19th century. But for each science, once we agree and we get a real nice model that we're all 100% on board with, and we've written our textbooks and we start from there, and then we get better instruments and better detailed things, suddenly the average person is left out of it entirely, and scientists communicate only to other scientists. And then chapter 6 is the one that talks about anomalies and how they work. And it's odd that a well-developed paradigm helps you discover more anomalies, and then those anomalies force you to change your paradigm. And he goes through multiple examples of how this works, from electricity, from the discovery of oxygen to the discovery of X-rays, and he ends up with a psychology experiment that is done with playing cards. So, his whole goal here is to say the traditional notion of history of science and how it progresses is problematic, and I, Thomas Kuhn, am coming up with this thing called normal science, this thing called a paradigm, and this thing called an anomaly. And through that, I can explain how science progress really happens instead of the sort of problematic and unworking notion you have of how science really happens. So that's all for now, and I will make a quiz on these materials. And here it is. It's midday Thursday. I'll probably have that quiz available by Friday evening. So by Monday at class time, you are to have read the 3 chapters that are in the PDF, looked at the PowerPoint that explains how to get from chapter 1 to chapter 6. You don't have to look at the other PowerPoint. That's something we'll do in class. And then take the 10-question quiz, which again, 8 of them will be objective questions, easy to answer as long as you just kind of find the spot in the text where it discusses that. And then 2 of them will be sort of open-ended questions for us to discuss in class on Monday. So I look forward to seeing you in a bit. Bye.